So today in class, we're going to be looking at systems of nonlinear equations. So in the past, we looked at systems of linear equations, and we use matrices to help us solve this. These are going to be nonlinear equations and systems, and we'll go about solving these. We're going to get a good practice of graphing because we'll graph these systems of equations, and then we'll look at solving them either using the substitution method or the elimination method. So you have a system of nonlinear equations in front of you. The first equation is x squared plus y squared equals 4. The second equation is y squared minus x equals 4. So you should be familiar with what the shapes of these graphs are. So let's graph the first one. So we have x squared plus y squared equals 4. You should be familiar that that is a circle. The center is at 0, 0. And our radius is equal to 2. So recall circles were in the form of x minus h quantity squared plus y minus k quantity squared is equal to r squared. So let's go ahead and graph that piece. So I'm going to go to the left 2, I'm going to go to the right 2, I'm going to go up 2 and down 2 from the center. And graph these. So now let's look at our second equation. Our second equation here is y squared minus x equals 4. And so it's only the y that is squared and not the x. So that clues me in that this is a parabola. Excuse me. It's just the y value that is squared. And so that clues me in that it is a parabola, but it's also going to either be facing left or right. So we know that this is a parabola. So we also saw that parabolas could be written in the form y minus k quantity squared is equal to 4 times p, and that is times the quantity x minus h. If it was in this form, we know where the vertex is. It's at hk. Depending on if the value, that coefficient in front of that x minus h is positive or negative, it tells me if I'm going to be facing towards the x-axis, the positive, or the x-axis in the negative direction. So let's go ahead and put that equation in that form. And so it's almost in that form. All I have to do is add x to both sides. And so doing so, I get y squared is equal to x plus 4. So it's in this form as of a parabola. I can see that my k value is 0, and my h value is going to be -4. So we have a vertex at -4, 0. So let's go out -4. The coefficient, I see that 4p is equal to 1. P is greater than 0, so I know my parabola shape is going to be opening towards the positive x-axis. So we can find a couple of other points to help us graph this. What about finding the y-intercepts? And so we can find those y-intercepts by letting x equal 0. So going in there, we have y squared, I'm going to plug it into the original, minus 0 equals 4. So looking at this, I have y squared equals 4. Taking the square root of both sides, I get y is plus or minus square root of 4. So y is equal to plus or minus 2. So looking at this graph, it looks like we figured out where our solutions are. Our solutions are the points where we intersect. And so it looks like our solutions are going to be at 0, 2, and 0, negative 2. But let's show that algebraically. So when we're solving these systems algebraically, we want to either use what is called the elimination method or the substitution method. So elimination method, we're going to be multiplying one equation by some constant, not 0. We might have to multiply the other equation by a non-zero constant. And so that when we sum them, the either x terms fall away or the y terms fall away, and we're left with one equation, one variable. So let's move over and rewrite our system and solve this algebraically. Okay, so now we just have the system of equations written in front of us. Again, we want to either do the substitution or elimination method. I notice that if I multiply one of these equations by -1, and I sum the two equations together, my y squared terms are going to fall away. And so let's do that. And it doesn't matter which one you choose. So let's do this equation 1. I'm going to just call it row 1. And then plus -1 times my second equation, which I'm just going to call row 2. Just kind of familiar notation of what we were doing before when we were doing systems of linear equations. So I'm going to rewrite my first equation, x squared plus y squared equals 4. Multiplying the second equation by -1, I'm going to get, and I'm going to rewrite them. I'm going to rewrite it so that the negative y squared is below the other y squared. But multiplying this through by -1, we get negative y squared. I'm going to have a plus x is equal to a -4. So now I'm going to just bring this over so that's lined up. So now when we sum these equations, I only have one x squared term. So bringing it down, x squared plus 0x squared is x squared. Y squared minus y squared cancels. I have a 0x in the first equation plus 1x is just x is equal to 4 minus 4, which is 0. So now we have one equation. Then we know how to solve this quadratic equation. So let's do this by factoring. So we can factor out an x from both of those terms. And so we're left with x times the quantity x plus 1 equals 0. So we're looking at when is x equal to 0? And when is x plus 1 equal to 0? And that's when x is -1. Okay, so we have our x values. We don't have our y value. And so we want to take each one of these x values separately. And we want to choose one of these equations. It doesn't matter which equation you choose. And we want to plug in that value for x and solve for y. Excuse me. So doing so, we have x equals 0. Let's plug it into the first equation. Again, it doesn't matter, but plugging it into that first equation, when x equals 0, we have 0 squared plus y squared equals 4. So we get y squared equals 4. Taking the square root of both sides, we get y equals plus or minus the square root of 4, which is positive and -2. So when x is 0, we have one point, which was 2. When x was 0, we have another point, y is -2. So now let's go back and let's see what happens when x is -1. So let's go back into our equation. So when x is -1. Choose one of them and plug it in for x. So -1 squared plus y squared equals 4. So -1 quantity squared is 1 plus y squared equals 4. Solving for y, we're going to subtract 1 on both sides. So we get y squared equals 4 minus 1, which is 3. Taking the square root of both sides, we get y as plus or minus √3. So we have 2 points here. When x is -1, y is -√3. And when x is -1, we have positive √3. So I want to go back and I actually want to check our solutions. When we looked at our graph, we saw that it looked like 0, 2, and 0, -2 were solutions. But let's check these. So to be a solution to a system of equations, we need to be able to go back and plug in our point to all of the equations in the system, and we better get back a true statement. And so let's look at that. So let's first look at maybe the point -1, -√3. So let's go back into the first equation and let's plug in what x and y are and see if we get a true statement. And so we have x squared, so -1 squared, plus y squared, so -√3 squared. Is this really equal to 4? So -1 squared is +1. -√3 quantity squared is +3. So we have 1 plus 3. Is that equal to 4? And it is. So it works for the first equation. And let's make sure that it works for the second equation. So plugging it into our equation 2, I have y squared. So I'm going to have -√3 squared minus x, which is -1. Is this equal to 4? So -√3 is our y value. -1 was our x value. So squaring -√3, I get back +3. Minus a -1 is +4. Not +4. I'm jumping ahead of myself. +1, which is equal to 4. So -1, -√3 is also a solution to our system of equation, which we really didn't see that when we had graphed our graph. Try now looking at when x is -1 and y is +√3. Well, I can see that I'm going to get the exact same thing, but let's just show it. So -1 squared plus √3 squared, show that that's equal to 4. Squaring -1, I get 1. Squaring √3, I get 3. 1 plus 3 is 4. Plugging it into the second equation, I have positive √3 squared minus a -1. Is that equal to 4? And we saw that positive √3 squared is +3 plus 1. That is equal to 4. I can see really clearly that if I plug those values back in, I will also get these points back in. I would also get that those worked for my system of equations. So I'm not going to check those. I'll let that you check those if you prefer. So we checked our solutions. We have 4 solutions. (0, 2, 0, -2, -1, -√3, and -1, +√3. So going back to our graph, it looks like that here at -1, we are also intersecting our graph. Okay, so we solved that by using the elimination method, but we also showed this by graphing. So we have another system of nonlinear equations in front of us. The first equation is x squared minus 3xy plus 2y squared equals 0. Our second equation is x squared plus xy is equal to 6. So I want you guys to be able to graph these. You should be familiar with what the shape is without even graphing or putting it into a standard form that we can see what the graph will look like. I'm looking at that first equation. I notice I have an x squared term and a y squared term in there. So that clues me in that I either have a circle, ellipse, or a hyperbola. I look at the coefficients in front of my x squared and y squared, and that should tell me what shape that is. So I have a 1 in front of my x squared, and I have a 2 in front of my y squared. Those are not the same numbers, so it's not a circle. Those are both the same sign. They're both positive, so that tells me that this is going to be an ellipse. The second equation, I'm looking at this, and I have just an x squared term and not a y squared term. So that clues me in that this is a quadratic equation. My x is squared, so it's either going to be facing up or facing down. Looking at it right now, it looks like it's facing upwards, but let's put these in standard form so that we can see what's going on. And actually looking at this, I see that I have x and y both in there times. So that does not look like what I was just telling you. Okay, so sorry about that scratch. What I was just saying about is that's an ellipse or a parabola because of this middle term here, xy. It's just not a single term. I'm not sure exactly what shape this is. So let's actually ignore graphing it for now. And we need to think about how we're going to solve this for either x or y. Looking at this, it looks like it's going to be hard to do the elimination method where I'm summing two equations and either all the x's fall away or all the y falls away. I noticed that this second equation, I just have one term with y. And so let's go over here and let's solve for y. So I can do that by subtracting x squared on both sides. So I would get x times y is equal to 6 minus x squared. So let's get y by itself. We can do so by dividing both sides by x. And so we would get y is equal to 6 minus x squared all over x. So right now I'm using the substitution method. So you want to solve for one variable in terms of the other with one of the equations, which we did. We solved for y in terms of x. Then you have to go back into the other equation. And so here, wherever we see a y, we're going to replace it with this 6 minus x squared divided by x. So let's go ahead and do that. We have x squared minus 3x. I see a y there, so I'm going to replace it. 6 minus x squared over x plus 2 times y squared. So 6 minus x quantity squared over x, and that quantity is squared, is equal to 0. So looking at this, bringing down my x squared, I have noticed that this x in the numerator here cancels with this x in the denominator. It's just because it's times that I can do that. Let's distribute our -3. So I have -3 times 6 is -18. -3 times negative x squared is plus 3x squared plus 2. Order of operations, I have to square this before I distribute that 2. So I have really 6 minus x squared quantity squared, my numerator squared. So I'm just going to rewrite that out. 6 minus x squared times 6 minus x squared all over my denominator quantity squared. So that would be x squared. Let me combine like terms on the one side. I have an x squared plus a 3x squared. That's a 4x squared. I have a -18 plus 2, so that's minus 16. Oops, no, don't add that 2. That's times. So minus 18 plus 2 times. So 6 minus x squared times 6 minus x squared. That's going to give me 6 times 6 is 36. I have a -6x squared minus a 6x squared is minus a 12x squared. And a -x squared times a -x squared is a plus x to the 4th. All over x squared equals 0. Okay, so now let's distribute our 2 to our numerator. So bringing everything over, I have 4x squared minus 18 plus 2 times, not 2, I'm multiplying, which I just said, 2 times 36 gives me 72. 2 times -12x squared is minus 24x squared. 2 times x to the 4th is plus 2x to the 4th. And those 3 terms are all over x squared equals 0. Okay, so we have an equation here, we have a fraction, we have x in the denominator, and so solving equations that have fractions, a lot of times we cleared our fractions by multiplying through by the LCD. So in this case, I want to multiply both sides by x squared. Distributing it. So x squared times 4x squared is 4x to the 4th. X squared times -18 is -18x squared. X squared times that fraction, the denominator cancels with the x squared, and we're just left with the numerator. So plus 72 minus 24x squared plus 2x to the 4th. 0 times anything is 0, so equals 0. So let's combine like terms on the one side. So we have a 4x to the 4th plus a 2x to the 4th gives us a 6x to the 4th. I have a -18x squared minus a 24x squared. So that is a minus 42x squared. And then I just have this plus 72 equals 0. So notice that 6 goes into all 3 of those terms, so I can factor out a 6. So pulling out a 6, I have x to the 4th minus 7x squared plus 12 equals 0. I can use substitution, or I see that this is factorable. This can be factored as x squared minus 3, x squared minus 4. So that each factor equals 0. I have 6 is equal to 0. Impossible. I have x squared minus 3 equals 0. And x squared minus 4 equals 0. So I can use the square root method in each case. So x squared minus 3 equals 0. add 3, take the square root of both sides, I get x equals plus or minus root 3. I can see x squared minus 4, x squared equals 4, take the square root of both sides, x equals plus or minus square root of 4, which is 2. So I have 4 different x values. I need to plug those back in to figure out what y is. And looking at this, it looks like probably the second equation is the easiest one to look at. I notice, oh no, it's not. So let's just go in and plug those values in and solve for y. So let's start with x equals negative root 3. So doing that, plugging it into the second equation, I have an x quantity squared, so negative root 3 quantity squared, plus x times y is equal to 6. Squaring a negative root 3, I get positive 3 back, minus root 3y is equal to 6. Let's subtract 3 on both sides. So I get negative root 3y equals 3. Divide both sides by negative root 3. We can leave it like that, or you should know how to rationalize your denominators. So we can clear the radical in the denominator by multiplying both the top and the bottom, the numerator and denominator, by root 3. So we get 3 root 3 all over negative 3, which is y equals negative root 3. So we have a point, just put it over here, that looks like it's a solution, but we have to check. So negative root 3, negative root 3. So we now want to do the same thing for x equals positive root 3. Going into the second equation, so positive root 3 squared plus positive root 3 times y, this is equal to 6. Squaring root 3, I get 3 plus root 3y is equal to 6. Subtract 3, so square root of 3y equals 3. Divide by square root of 3, I got 3 over root 3. Rationalize my denominator. I get 3 root 3 over 3, which is just root 3 when I simplify. So I have another point. When x is positive root 3, y is also positive root 3. Okay, so we've plugged in those x values. We now want to plug in our x values of positive 2 and negative 2 for x and solve for y. So let's first look at x equals negative 2. So I'm going to just move the screen over. Going into the second equation and plugging in negative 2 where I see an x. So I have negative 2 quantity squared plus negative 2 times y is equal to 6. Squaring negative 2, I get 4 minus 2y equals 6. Isolate our y so we can subtract 4 on both sides. I get negative 2y equals 2. Divide by negative 2, I get negative 1. So I have another point, negative 2, negative 1. And the last x value, x equals 2. We want to plug that in wherever we see an x and solve for y. So I have 2 squared plus 2 times y is equal to 6. 2 squared is 4 plus 2y equals 6. Subtract 4, I get 2y equals 2. So I get y is 1. So I have another point that looks like a solution, but I have to check it, is 2, 1. So we want to go back into each one of these equations. We want to plug in what x and what y is and show that we get a true statement. Well, I know that those actually work when I plug them into the second equation if I did everything right, because that's how I got my y value. So let's just plug these into our first equation and see if that's true or not. Okay, so looking at the first equation, let me just write it down here. X squared minus 3xy plus 2y squared equals 0. So let's plug in negative root square root of 3, negative square root of 3, and wherever we see an x and a y. So negative root 3 squared minus 3 times negative root 3 times negative root 3 plus 2 times negative root 3 squared. Is that really equal to 0? Well, square root, our negative square root of 3 quantity squared is just 3. Minus, well, negative root 3 times negative root 3 is positive 3. Positive 3 times that negative 3 out front is negative 9. So 3 minus 9. And then I have a negative root 3 quantity squared, which is 3, times that 2 in front here is 6, so plus 6. Is that equal to 0? And it is. Okay, so negative root 3 does work. So do the same thing now for positive root 3 times positive root, or not positive root 3 times positive root 3, the point root 3 comma root 3. Same thing, gonna go in here now and plug in root 3 wherever I see an x and root 3 wherever I see a y. I notice I'm gonna get the exact same thing because of that squared here. And I'm multiplying the same thing here. So that one's gonna work. So let's just jump down to negative 2, negative 1. So if I square negative 2 minus 3 times negative 2 times negative 1 plus 2 times negative 1 squared, is this equal to 0? Squaring negative 2, I get 4. I have negative 3 times negative 2 is positive 6. Positive 6 times negative 1 is negative 6. Negative 1 quantity squared is 1 times the 2 is plus 2. This is equal to 0. Same thing. I can see that plugging in positive 2 and positive 1 is going to give me the exact same thing that I got when I plugged in negative 2 and negative 1 because of the square and the multiplying here. And so this one is also going to work. So those 4 points that we found are solutions. So let's look at the graph of that and show those are where those two graphs intersect. So we graphed this on Desmos and notice that we are intersecting in 4 spots, negative 2, negative 1, which we got, negative 1.732, which is negative square root of 3, negative 1.732, which again is negative root 3, and then up here, root 3, and 2, 1. And so what we did correctly. Okay, so we have another system of nonlinear equations in front of us. We have log base x of 2y, that is equal to 3, and we have log base x of 4y is equal to 2. So I have 2 log equations. To me, it looks better when they are in exponential form. So let's rewrite these in exponential form. And so this first log, my base is x, so that's the base of my exponential. So I have x cubed is equal to 2y. The second equation, rewriting in exponential form, my base is x, so that's the base of my exponential. So I have x squared is equal to 4y. So maybe let's solve for y in each case. Doesn't matter. I'm thinking we're going to want to do substitution method. So we want to solve for y in one case and plug it into the other. And so maybe let's solve for y in the first equation. So I can get y by itself in that first equation, dividing by both sides by 2. So I would get y is equal to x cubed divided by 2. So I'm going to go in here, wherever I say y, I'm going to rewrite it with x cubed over 2. So doing so, I get x squared is equal to 4 times y, but that's x cubed over 2. So now I have one equation with one variable. I notice my 2 in the denominator here goes into this 4 twice. So I have an x squared equals 2x cubed. I notice that this is nonlinear. So I want to get everything to one side and set it equal to 0. So I can subtract x squared on both sides. So that would give me 2x cubed minus x squared equals 0. I notice I can factor in x squared out of both of those terms. So factoring out an x squared, I'm left with 2x minus 1 equals 0. So I'm looking at when is x squared equal to 0 and when is 2x minus 1 equal to 0. Well, x squared is equal to 0 when x is 0, and 2x minus 1 is equal to 0. Add 1, divide by 2, so we get x is 1/2. So these are our x values. We have logs, so we have to worry about domain. Our base of our log has to be bigger than 0 and can't be 1. And so here, x equals 0 right away goes away. It's not in the domain of our log. So now let's plug in 1/2 for x and we'll solve for y. So choose which equation you want to use. Looking at this, maybe the second one's easier. So I have log base 1/2 of 4y is equal to 2. So this is saying rewrite an exponential 1/2 squared is equal to 4y. So I have 1/4 equals 4y. I can multiply both sides by 1/4 to get rid of the 4 in front of my y. So then I get y is equal to 1/16. So when x is 1/2, y is 1/16. So that would work for the second equation. Let's just make sure that works for the first equation. So I have log of x, my x value is 1/2 of 2 times y. Y I found to be 1/16. Is that equal to 3? Reduce a little bit. So log base 1/2 of 2 times 1/16 is 1/8. Does that equal 3? Is 1/2 quantity cubed equal to 1/8? Yeah, because if I cube my numerator, 1 cubed is 1. Cube my denominator, 2 cubed is 8. 1/8 equals 1/8. So we do have one solution, 1/2, 1/16. And so if we graph those are where they would intersect one another. Okay, so let's look at one more system of nonlinear equations. I have x squared plus 4x plus y squared minus 4 equals 0. I can tell that that's a circle because we have an x squared and a y squared. Both of the coefficients in front of x squared and y squared are the same. My second equation, I have y equals 4 over x plus 2. I have a rational function. So we should be able to tell if we have vertical asymptotes and horizontal asymptotes and graph from there. Let's rewrite that first equation so we can graph it. Let's put it in the form that we can tell where the center is. So I have x minus h quantity squared plus y minus k quantity squared is equal to r squared. So I want to group my x terms together, group my y terms, well, there's just one y term together, and get the constant on the other side. And so x squared plus 4x, I want to make this a perfect square. So I'm going to add some number on this side of the equation to make that a perfect square, plus y squared equals 4, adding 4 to both sides. But if I add something on the left-hand side, I have to either add it on the right-hand side or I have to subtract it off on the left-hand side. So it's like I'm adding 0. That number that would make x squared plus 4x a perfect square, we'll divide 4 by 2 and square it. So 4 divided by 2 is 2, 2 squared is 4. Add 4 to both sides. So here is a perfect square. X plus 2 quantity squared plus y squared is equal to 8. So here I can tell my center, HK, so -2, 0. And my radius, well, r squared is 8. So r is equal to, normally I put plus or minus root 8, but it's a length. So it's just going to be positive root 8. Well, square root of 8 is square root of 4, which is 2, times square root of 2. So graphing that, I'm going to go over -2. That's my center. And then I'm going to, from there, go left, right, up, and down to root 2. So the square root of 8 is approximately 2.8. So up about 2.8, down about 2.8, left about 2.8, right about 2.8. By doing so, you get a circle that looks about like that. Graphing this one, I see that my denominator is equal to 0 when x is -2. X equals -2 doesn't also make my numerator equal to 0. So that means I have a vertical asymptote at x equals -2. I noticed that my degree of the denominator is larger than the numerator. So that means I have a horizontal asymptote at y equals 0. Looking at this, I'm never going to cross the y-axis. Am I going to cross the y-axis? Yeah, if I let x equals 2, I get 2. So it is going to cross at 2, which looks like that could be the point on our graph. My x-intercept is never going to happen because if I let y equals 0, I get 0 equals 4. So I'm going to have something that looks like this. I'm not sure if it's going to cross more than once or not. So I'm either above or below the x-axis when x is less than -2. And so I could figure that out by plugging in a point to the left of x equals -2 to see if it's positive or negative. So if I chose, let's say, x equals -3, and I plugged it in here, I get 4 all over -3 plus 2. That's 4 over -1, which is -4. So it's down here. So knowing that and where my asymptotes are, I can tell where my graph is going to look like. So again, I'm not sure if I'm going to be crossing twice or once, and I'll know more when I solve for my solution. Okay, so let's solve for our solution. We want to go back in and plug that value back in for y. I have this y equals for my second equation, so I might as well do substitution method. So we're looking at the system equation. We just went in and we plugged in 4 over x plus 2, wherever we saw an x in the first equation, actually, wherever we saw a y in the first equation. Notice that we have a fraction here, so we can clear that fraction by multiplying through by our LCD. Our LCD in this case, though, is x plus 2 quantity squared. Technically, when I distribute, it will be easier, I think, if I distribute with that already multiplied out, x plus 2 times x plus 2, which gives us x squared plus 4x plus 4. Distribute that out. So on this one side, we're going to distribute that x squared to all three terms. So I have x squared times x squared is x to the 4th. X squared times 4x gives me 4x cubed, so plus 4x cubed. X squared times 4 gives me plus 4x squared. Now let's go through and let's distribute our 4x to each term. So 4x times x squared, that gives me plus 4x cubed. 4x times 4x, that gives me plus 16x squared. And 4x times 4 gives me plus 16x. So now we're distributing our fraction to this. The whole point was so our denominator went away. So all I'm left with is my numerator squared. So 4 squared gives me plus 16. Now let's distribute the -4 to each term. So -4 times x squared, -4 times 4x, and -4 times 4. Doing so, -4 times x squared is -4x squared. -4 times 4x gives me minus 16x, and -4 times 4 is minus 16. This is all set equal to 0. Combining like terms, I only have one x to the 4th term. Looking for my cubes, I have a 4x cubed plus a 4x cubed. That's plus an 8x cubed. Looking for my squares, I have a 4x squared plus a 16x squared. That's 20x squared minus a 4x squared gives me plus 16x squared. Looking at just my terms with x, I have a 16x minus a 16x, those cancel. And then I also have my constants. I have a 16 minus a 16, that also cancels. So then that equals to 0. I notice I can factor out an x squared from all three of those terms, which would leave me with x squared plus 8x plus 16 equals 0. I notice that's factorable. So I have x squared. I have x plus, is that factorable? Yeah, x plus 4 times x plus 4. So x plus 4 quantity squared equals 0. So I'm looking at when x squared equals 0, that's when x is 0. And I'm looking at when x plus 4 is equal to 0. And that is when x is -4. So we have our x values of the point or points of where we think it's going to be crossing. we want to go back in and we want to either plug that into the first or the second equation. So let's plug it into the second equation. So here we have y is equal to 4 over x plus 2. So when x equals 0, I get 4 over 2. So y then is 2. So I have that point 0, 2, which we talked about. Looked like it was intersecting. And now let's look at when x is negative 4. So going back into this equation and plugging in negative 4. So plugging in negative 4 in the denominator, I have negative 4 plus 2, which is negative 2. 4 divided by negative 2 is negative 2. So y would be equal to negative 2. So we have 2 points, 0, 2, and negative 4, negative 2. The graph is a little off. It's right here. So I'll let you check those, but those would be those solutions to that system of equations. Okay, so that's systems of nonlinear equations. And now we'll start a new video looking at systems of inequalities. So instead of the equal sign there, we have a less than or equal to, greater than or equal sign. But I'll put that in a different video.